Salam and hi all. Now we will look at the subtopic 2.5 prediction and goodness of faith. The model that we constructed, the model means that the estimated equation can also be used for prediction or forecasting purposes. Prediction is defined as inference about out of sample observations. There are four basic guidelines in using simple linear regression model for prediction as given here. The ability to predict is important to business such as in sales forecasting and important too for policy makers such as in forecasting of output or predict the inflation, since accurate predictions will give the better decisions. A prediction interval, much like a confidence interval, is a range of values in which the unknown value of y is likely to be located. In prediction interval, the starting point here is y naught hat. The formula for prediction interval for simple linear regression is given by this formula. Okay. When standard error for forecast sigma hat squared, variance beta 2 squared, x naught, x bar naught, and n are defined by this equation or definitions. Goodness of fit measure the correlation between sample values of y and their predicted values, which is denoted by r square. The r square value describes how well the model fits or good to the data. Now let's look at example 2.51. Again, consider the data of example 2.2. In the study, an executive might ask of the research staff, give me an estimate of average weekly food expenditure by household with RM2000 weekly income. Means that from the question, the research staff need to predict weekly food expenditure, predict y hat, for a household with a weekly income of RM2000 weekly income, that is x. And since the unit for x for the data that is in RM100, so for RM2000 this is the same as x equal to 20. So the question give us that the estimate of average, okay, the average here, the estimate of average means that this is E of y given x, where x here is equals to 20. And since the word of estimate, so that's why we need to put hat here. So means that the question asks us to get the expected value, okay, of y given x equal to 20. So the point estimate of average weekly food expenditure for a household with RM2000 income will obtain by using this formula. Okay, so by using the fitted model here, okay, that we construct from the previous example, okay, and substitute x here equals to 20, so we will get the estimated value, that is 287.608. Okay, to interpret the value, that is we predict that a household with a weekly income of RM2000 will spend RM287.61 per week on food. Now, let's continue to example 2.52. In this example, we want to attach the prediction interval to the point prediction in example 2.51. Why not had here is the notation for the point prediction, which gives the value of 287.608. This obtained from example 2.51. By applying the prediction interval formula given in this slide, okay, and its related formula here, we can construct the prediction interval in example 2.52. Note that sigma hat squared here is the square of standard error of regression, where the value of standard error can be obtained from regression statistics of simple linear regression output, while variance B2 hat here is the square of standard error of B2. The standard error of B2 can be obtained from coefficient table of simple linear regression output. Okay, the value is here. Substitute all the values of sigma hat squared, variance B2 squared, okay, but here, and number of data here, 20 here actually is the x naught, where x naught is the value of x for corresponding value of y naught. Okay, and this value is come from x bar. X bar is the sample mean for data x. Okay, so we can get the value of standard error for forecast now is 90.6328 at 4 decimal places. Okay, so to get the prediction interval, and by looking at alpha value here, so we can see that alpha is not given, so we need to use standard alpha, and standard alpha is 0.05. Means that this is the same as 95% prediction interval. So that TC here, okay, where C here is alpha must be divided by 2 with a degrees of freedom. Okay, so our alpha is 0.05 divided by 2, so we get the value of 0.025 with a degrees of freedom. Okay, this is come from n minus 2. Okay, we have n equals to 40. Okay, minus 2 because this is under simple linear regression. Okay, and then we get this value, okay, from statistical table for the corresponding t. 0.025 with its degree of freedom 38. So the 95% prediction interval is given by this one. Okay, so this is the lower prediction interval, and this is the upper prediction interval. Note that this prediction interval is come from when we substitute all the value of y naught hat here, plus minus, okay, this is TC, and this is the SE for forecast. Okay, and the prediction interval here suggests that a household with RM2000 weekly income will spend somewhere between RM104.1 and RM471.11 on food. Now we are discussing example 2.53. Again, consider the data of example 2.2. In this example, we want to look how well the estimated linear regression model that obtained from the previous example fits the data. And in this example, we want to use the goodness of fit approach. From the regression statistics of Excel output, given here the value of R square is given by 0.3850 at 4 decimal places. So the interpretation for this value, that is, we conclude that 38.5% of the variation in food expenditure is explained by the regression model, which uses only household income. Even though this value is not so high, note that we should not evaluate the quality of the model based only on how well it predicts the sample data used to construct the estimate. To evaluate the model, it is as important to consider other factors such as the sign and magnitudes of the estimate, their statistical and economic significance, the precision of their estimation, and the ability of the fitted model to predict value of Y that were not in the estimation sample. Other than using Microsoft Excel, we also can use R language to get the output for simple linear regression model. By using the following R codes here, to the data of example 2.2, we can get the scatter plot as shown here. And the R value. R value is the correlation value. The correlation analysis actually leads to the same conclusion as R square. By using R, we also can get the simple linear regression model, and the output is as shown here. That's all for chapter 2. See you in the video of chapter 3 soon. Thank you.